All right, welcome back. In video 2, we worked with individual propositions, truth values, and negations. Now I'm going to take propositions and combine them. Okay? Because once two propositions are combined, the truth value of the new statement depends on two things. All right? The truth values of the original propositions and the logical operator connecting those two things. Okay. So the four operators that we're going to use are conjunction, right? When you use the word, when you use conjunction or when it has P and Q, what you want to look for is P and Q. Okay. So that essentially means the same thing. Disjunction or the usage of or, true when at least one part is true. So a disjunction would be P or Q. Also, the symbolism would be P or Q. Okay. And then a conditional statement is if P then Q, false only when P is true and Q is false. So the way that looks is P if P then Q. Actually, I did that backwards. So this should be, I'm just going to write it backwards. So essentially what it is if P, then Q. Okay. So just understand that this would be the words. If this, then that. If I study for Mr. Dickerson's test, then I will pass his test, right? So it's false only when P is true and Q is false. So if you study but you do not pass, and then guess what that means? So that's the conditional statement because it's basically a hypothetical. If you study, you will pass. Okay, that's how it works. All right. So again, this is the symbolism, and these are the words. Biconditional, P if and only, excuse me, P if and only if Q. So it's true when truth values match. Okay, so um, P if and only if. So that the way that looks is okay. That's the symbolism for that. All right, and so we also, are going to continue using, the negation symbol as well. Okay, so anytime you see that, that's a negation symbol. Okay, let's jump right in. So example number 1, right? Um, the thing you got to understand is this, all right? So we need to begin with the language of this idea. Okay? We got to begin with the language of this idea. So when we say, P and Q, right? P and Q. What we're saying is this. P What we're saying is the conjunction is true only when they both are true. All right. So if we say T and T, then that's going to be T, right? If both are true, then the outcome is going to be true. But if you have a T and a false, or a false and a T, or even a false and a false, then the outcome is just going to be false for all of those, right? Consider, what if I said, I am going to school and I am going to practice. If I do both of those, then I told the truth, right? If I only do one of them, which is what this means, then and was inappropriate, so it's false. Again, if I did the first one and not the second one, then it's not true. And then if I say I'm going to class and I'm going to practice, but I don't do either, then guess what? It's still false. So the only way that an and proposition can be true is if both statements are true. That's how that language works for the conjunction and. Okay. How does it work for disjunction if we have P or Q? The way P or Q works is unless otherwise stated, the word or is um the word or in formal logic is inclusive. So what that means is it's true when one of them are true or both of them are true. Okay. So essentially, if both of them are true, then the outcome is true. If the first one is true and the second one is false, then it's a true statement. If the first one is false and the second one is true, then it's a true statement. Then, but if both of them are false, then it's obviously false. Okay. But the only false row is when both of them are false. Because again, I can say, I can read or cows can fly, right? Well, one of those statements is true because I can read, but cows can't fly. So it's still a true statement because only one of them need to be true. Okay. That's why all of these are true and the only one that is false is the bottom row. Okay. Now, a conditional statement, or also known as an if then statement, is a contingency. So the proposition P is called an antecedent, right? So when we're thinking about the if then, right? So if P, that's an antecedent, and then Q would be called the consequent. Okay. So if P, the antecedent, then Q, the consequent. So a condition is false in exactly one truth value combination. That is, if you have if the first preposition is true, but the conclusion is false, then the outcome is going to be false. Everything else in this scenario is going to be true. So if you have an if then that's true, and then it tends to a truth, then the outcome is going to be a truth. If you have a false premise that leads to a truth, then the outcome is going to be true, right? Because the outcome became true. And then if you have a false that leads to a false, then the outcome is going to be true. Okay. So that the row you absolutely need to remember is this one right here. A truth, if this is true, then this is false, becoming false. Okay. Biconditional statement. A biconditional has the form of, again, if and only if, right? So a biconditional is true whenever P and Q have the same truth value. So essentially, if we have a biconditional, we would say that, if it's, oh, excuse me, that should be true. So if and only if P, if and only if Q, they must have the same truth value. Okay. So if they have the same truth value, then the outcome will be true. Same thing for here. So if it's false, if and only if it's false, then the outcome would be true. Okay. Everything else essentially would be false. So if it's true, if and only if false, then the outcome is false. False, if and only if true, then the outcome is also false. Okay. So the shortcut is basically, the same truth value, therefore it's true. Same different values right here, false. Okay. If they have the same truth value, then they're both true. They have the same false value, then they're both false. Okay. So I know that's a lot, but I had to go over those very quickly. Example number one. Let's put these into practice. So it says, let P be the source is identified, and Q be the data are current. Okay. So again, this will be P and this will be our Q. Then it says evaluate P and Q when the source is identified, but the data are outdated. Okay. So here we are. We're told that the source is identified. Therefore, P is true, right? The source is identified. But we are also told that the data is outdated. So if the data is outdated, then that would make Q false. And then it says we need to evaluate P and Q, right? So if we substitute P and Q for this data, we had P and Q, we would substitute it and it would become true and false, right? Remember that a conjunction requires both propositions to be true, right? If both propositions are true, then using the conjunction and will work. But if only one of them is true, like this, then guess what? The outcome is false. So P and Q is false. The compound statement, the source is identified and the data are current, is a false statement. Why? Because only one part is true, and that is this, or excuse me, that is the source is identified. That part is true. The data are current, right? That part is false, right? All right, let's continue. Example number 2. A scholarship requires financial need or academic merit. Explain the inclusive meaning of or and identify which applicants qualify. Okay, so again, suppose a scholarship, requires, financial need or academic merit. So we're going to let P be the student demonstrates financial need, okay? Okay, the student demonstrates financial need, and then we're going to let Q be the student demonstrates academic merit. Okay, I just wrote these right here to avoid writing the same thing over and over. Okay, or over again. Demonstrates financial need, student demonstrates academic merit. Okay, so the requirement can be represented as P or Q, right? Because this is an inclusive or, let's examine 4 possibilities, right? The 4 possibilities are that we could have true, true, we could have true, false, we could have false, true, we could have false, false. So in any 2 situations like this, when you're dealing with, 2 possible outcomes, you know, uh, financial need or academic merit, that's essentially 2 squared. Okay, 2 squared is 4. So you have 4 possible outcomes, right? You can either get both of them, both statements being true. You can get the first one being true. You can get the second one being true, or you can get both of them being false. Okay. Now, when we line them up with respect to or, then we only need one of them to be true, right? Because if the student has financial need and academic merit, right? If they need financial aid and academic merit, right? Then the student qualifies, right? Because they only need one, but let's just say both of those are true, then they'll still qualify, right? If the student has financial need, if they have financial need, but they don't have the academic merit, well, guess what? They'll still get the scholarship. If the student does not demonstrate financial need, but does demonstrate academic merit, guess what? They're still going to get the scholarship. Now, the student still qualifies. Now, only when neither condition, notice, There is no evidence of a financial need, no evidence of academic merit. Therefore, they're not going to get the scholarship. Okay, so the student does not qualify in that situation. The key rule is this: P or Q means at least one of the two propositions must be true. Okay, must be true for at least one. All right, try this. Okay, so if a poll is random, then it is automatically unbiased. Let P in this scenario, let's let P be the poll is random and Q be the poll is unbiased. Okay. Poll is random and Q is poll is unbiased. Okay, because that's two prepositions, right? If, then, and then enclosed in the if is a poll is random. So poll is random, then automatically unbiased. So the poll is biased. That's essentially what it is when you want to break this down. Evaluate the conditional when P is true and Q is false, and then explain what the false row reveals. Okay, so again, this is a P. This is how it would be written symbolically. Okay, so suppose we discover a poll for which P is true but Q is false. So we would have essentially, a truth, leading to a falsehood, right? Um, but remember the rule, right? Because a conditional is false when the antecedent is true and the consequent is false, right? So the rule is if you have a truth and the conclusion or the consequent is false, then the outcome will be false. So P tending to Q will lead to a falsehood. But what does that mean in this example? It means that we found a poll that was random, right? We found a poll that was random, but it was not unbiased. And so that provides a counter example to the statement that if a poll is random, then it's automatically unbiased. So the original statement claims that whenever this occurs, right? If a poll is random, then it automatically is unbiased. So they're making this claim saying that all random polls are automatically unbiased, right? If a poll is random, then it's automatically unbiased, right? That's what they mean. But you know, a counter argument to that was if a poll is random, or excuse me, the counter argument to that would be if a poll is random, then it is automatically unbiased. But the original statement claims that whenever P occurs, Q must follow. Okay. Again, a counter to this would be, um, or what they're essentially saying is, it means that we found a poll that was random but was not unbiased. That would provide a counter argument to this particular claim. Because if all I need to do is find one poll, right? One random poll and find that it wasn't biased, right? That's all you need to find in order to prove that this is false. Okay? That's why this conditional statement will always be false, because all I need to do is find out one of them and then I can prove that it would be false. Okay? So therefore this conditional statement fails miserably. All right? Let's continue. Example number 3. All right, construct a truth table for not P or Q, where P means the article cites evidence and Q means the article links the original source. Okay, so the article cites evidence, that would be P, and Q, the article links the original source. So we have two propositions, P and Q. All right, so the article cites evidence, that's going to be my P, and the Q is there. All right, so again, let's start with, first of all, um, with the categorical table. So we have P and Q. So we know for a fact we're going to get both of them must be true. We can get true, false, false, true, get false, false, right? Okay. Now we need the negation of Q, right? So the article cites, and Q means the article lists the original source, but it says construct a table for not P or Q. Okay. So we need the negation of P. And so remember, when we negate P, the negation of a truth value is if P is equal to true, then the negation of P would be false. Okay. And then if P is false, then the negation would be true. And so what I'm going to do is I'm going to show you that here. So if we did not P would be, not this would be false, not true would be false, not false would be true, not false would be true. That's how you negate the original preposition. Okay. Now, what we want to do is we want to evaluate not P or Q. So not P would be not P. Oh, that's and. Would be not P or Q, right? So or, that's an or statement. So we have not P or Q. So we know what the Q values are. The Q values don't change. So we have true, false, true, false. And then we have our new column. We have false, false, true, true. And now remember, when you have an or statement, right? When you have an or statement, right, you only need one of them to be true. So if we have not P or Q, you only need one of them essentially to be true in order for it to be true. That's the bottom line. So here, this is going to be true. This right here, when you have a false and a false, well, that outcome is a false. Here, we only need one of them to be true. Here, we only need one of them to be true. So the values of this particular new table would be true, false, true, true. And we can test those logically by infusing the new information into the table if we were to write these out and make them make sense in the grand scheme of things, okay? All right, let's continue. Example number 4. Consider the statement. If a claim is verified, then publish it. So we're going to let P be the claim is verified, and we're going to let Q be the claim is published. Okay? The original conditional is if P, then Q, right? If a claim is verified, then publish it. Okay, so if we put that in context, if we put this in context, if the claim is verified, then the claim is published, essentially, right? If the claim is verified, then the claim is published. The converse, right? So this would be the initial statement, and then with its converse. So the converse essentially switches P and Q. Okay. So converse switches P and Q. So if we start with P, if P then Q, then the converse would be if Q, then P. Okay, so the converse basically switches the statements. So in context, it would be if the claim is published, then the claim is verified. And notice how I just switched the prepositions, right? Because P is if the claim is verified, the claim is published. The converse of that would just be putting Q first and then P second. If the claim is published, then the claim is verified. That's all it is. The converse is just switched. It's the inverse of a conditional statement. So conditional and converse are inverses. Conditional statement and converse are inverses, okay? But be careful because the converse is not automatically equivalent to the original conditional, right? The original statement tells us that verified leads to published, but it does not establish published means verified, right? Because you can have something that's published and not verified. Understand? Okay. But you can have something that's verified and therefore it's published. Okay, so that reverses the direction of the reasoning, right? And then contrapositive, right? Okay, the contrapositive. So if we started with P, if P then Q, the contrapositive first switches P and Q and then negates both prepositions to the point where it would be not Q, not P. Okay, so that's what the contrapositive is. So in context, it would be if the claim is not published, then the claim is not verified. Okay? That's what you got to understand. So contrapositive is basically you flip the preposition, right? It's like the converse. You flip the preposition around and you negate them both. If the claim is not published, then the claim is not verified, right? Common, as a matter of fact, let me see. Identify which statement is logically equivalent to the original. Okay, so with respect to this now, what you got to understand is the equivalence is important, right? Because if I say if the claim is not published, then the claim is not verified, right? The conditional statement and the contrapositive always have the same truth values, but the converse does not automatically have the same value. Because again, if I said the claim is verified, excuse me, if the claim is verified, then the claim is published because it means that, you know, essentially you had to verify it before it was published. And then if I turn around and say if the claim is not published, then the claim is not verified. Notice how this preposition or this argument aligns perfectly with this because they're going to have essentially the same truth value each time, whereas this will not necessarily have the same truth value as the others. Okay. Common mistake. Suppose the requirement says that applicants need a license or certification as requiring both. Use a truth value or a truth table row to correct the misinterpretation. So let's make P be the applicant. I'm going to abbreviate applicant. The applicant has a license. Okay. And then we're going to make Q be the applicant has certification, right? Because that's the applicant. I mean, that's the argument. Applicant needs a license or the applicant needs a certification. The applicant has a license or the applicant has a certification, right? So the statements the statement's uses an or, right? It's P or Q. Now, again, suppose we want to suppose that P is true and Q is false. So let's evaluate that, right? Because a student treats applicants need a license or certificate as requiring both, okay? But again, when we're evaluating or, right, because or essentially only needs one. So the applicant in this case satisfies the requirement. The student does not need both conditions. Now, let's compare that with an and statement. So they only need one here. Okay. They only need one to qualify for that. Now, if the requirements were the applicants need a license and a certificate, so if it was both, right? If they needed a license and a certificate, then, we would essentially say if this was true and this was false, then the outcome would be false. Unlike this one, you only need one of them to be true. Okay. So again, that difference is extremely important when you think about it. The student treats applicants need a license or certificate as requiring both. Use a truth value row to correct the interpretation. If you use the word or, you only need one classification, right? But as requiring both wouldn't necessarily satisfy because he uses the word or here. And so you cannot confuse the word or with the word and, because then if that's the case, then, this student wouldn't qualify. But based on this statement, the student does qualify. So he used the wrong conjunction in his analysis. Okay. So if we use the table for this, um, again, this is essentially saying, true, true, false, actually true, false, and then false, true, and then false, false. Okay. So if we used this value and we used an or, just remember you only need one of the values to be true. Okay. Because applicants need a license or a certificate as requiring both is irrelevant, because if you use the word or, you only need one of those requirements. Okay. So um, one of them must be true if you're using the disjunction. Okay. So or is a disjunction, and if we were using and, that would be a conjunction. So that would mean that both of them must be true. Okay. So again, I just want to go back over here. These are your tables. Okay, so again, this is a conjunction and, where both statements must be true. If both statements are not true, then the outcome is going to be false. Just remember that. In a disjunction where you're using the word or, all of them are going to be true unless one of them is false. In an if-then statement or conditional statements, the first part is called antecedent. The second part is called consequent. The only time it's false is when the premise is true and the conclusion is false. Any other time, the result is going to be true. In biconditional statements, if they have the same truth value, they're both true. If they have different truth values, then they're both false. It's that simple, and you can easily memorize this. It becomes very easy if all you have to do is just keep writing it down, and I promise you, you'll commit it to memory very, very quickly. Okay. All right. So I just want to close with that, and make sure when you're doing these, you're doing the corresponding examples on your video companion, and complete the corresponding problems on that PDF, and then make sure you understand the language so that you can do well on the math language assignment and the video check at the end of the week. But again, I hope you've enjoyed this, and I'll see you in the next one.